So main topic of chapter 6, solving systems of equations. So a system is made up of two or more equations. Where solutions must work for all the equations. As just kind of a quick example here. Two sets of equations, y equals x plus 1, y equals 2x minus 1. Okay, solution is 2, 3. Okay, because when you plug 2 in for x and 3 in for y, you get two true statements. Top one being 3 equals 2 plus 1. 3 also equals 2 times 2 minus 1. And we're going to talk about how do you come up with these solutions. So there's three different ways we're going to talk about solving. The first one is to solve by graphing. When we're doing that, we're going to graph both equations. And wherever they intersect, is your answer. So let's just use that same set of equations that I had above. So we graph each one, y equals x plus 1. We start with our y-intercept of positive 1. Have a slope of 1. So our first graph looks like that. Next one, y equals 2x minus 1. Start with our y-intercept of negative 1. And we have a slope of positive 2. So again, our point of intersection ends up being our solution. So in this case, they intersect at the point 2, 3, just like we got up there. All right, so answer to this system would be 2, 3. X equals 2, y equals 3. In that blue. Another example here, y equals negative 3x plus 4 and y equals 3x minus 2. Graph the first one, y-intercept of 4. 1, 2, 3, 4. Slope of negative 3. So graph, sorry, 4, slope of negative 3. So we got our first line there. Next equation, we start at negative 2. Slope of 3. All right, so again, here's our point of intersection. This time it's at 1, 1. There we go. Yes, sir. All right, one more example here. Y equals x minus 3, y equals 7x plus 3. Graph each one of those. First one, y-intercept of -3 with a slope of 1. Second one, y-intercept of 3, slope of 7. All right, looking for the point of intersection. This case, -1, -4. Have you guys try these two on your own? All right, so looking around, everyone's doing a pretty good job. Struggling graphing a little bit. Gonna definitely need to have that down. So on the first one, -4x plus 2. Start here, go down 4/1. Other one, x minus 3. Okay, so we're looking for the point of intersection, ends up being right here at 1, -2. On the second one, notice that they have the same slope, different y-intercepts. So if they have the same slope, okay, they're never going to intersect. So what that means if two graphs never intersect, then there is no solution to the system. Okay, so for the most part in this class, we'll only be dealing with lines. Future classes, you'll have parabolas and circles and a whole bunch of other stuff that might not intersect. Okay, when it comes to lines, okay, the only way they don't intersect is if they have the same slope and different y-intercepts. Outside of that, every other graph, line graph will intersect. So we would use, like I said, there's multiple methods to solve systems. So we would want to use solving by graphing. If the two equations are easily graphable, what a word? I don't know. It is now. So we'd really only want to use this if we were able to graph. If we got a really complicated equation that wasn't easily graphable, okay, we wouldn't want to try and figure it out. We still could. But another method that we can use is called the substitution method. And we're going to use this whenever a variable is on a side by itself. And we can plug it into the other equation. Show you what that looks like. Give me a second to get caught up here. All right, so we have this new set of equations. X equals y plus 13, 4x plus 2y equals 10. Okay, can we easily graph these? Not really. Okay, we can figure it out, move the x or move the 13 over. Okay, but an easier way in this instance would be to use the substitution method. And all that means is we have a variable on a side by itself over here is x. So we know that x is equal to this, y plus 13. So all we're going to do is we're going to take that and we're going to plug it in for the x in the second equation. So now what we're left with is 4 times y plus 13 plus 2y equals 10. We're going to distribute that 4y plus 52 plus 2y equals 10. And we're just solving for y now. So combine like terms, 4y and 2y gives us 6y plus 52. Subtract 52 from both sides. (6y equals negative 42). Which gives us y, then divide by 6. So negative 42 divided by 6 then means y is equal to negative 7. All right, so we found our y. We still need to find the x. All right, so what we're doing now is we've got to take this y value, plug it into either equation. Usually the opposite one's going to be easier because x is already on a side by itself. So now x equals -7 plus 13. X equals 6. So now my solution is 6, 7, -7. All right, definitely a little bit more math involved with this method. Okay, this part right here, obviously a lot of chances for mistakes. Take a look, another example here. All right, so y on a side by itself, actually fairly easy because there's no x value, so we're just taking that in and plug it in for our y down here. So I get 5x plus 4 times -5 equals -20. 5x minus 20 equals -20. Add the 20 to the other side. 5x is equal to 0. Divide both sides by 5. Okay, 0 divided by 5 is still 0. Okay, so on my x value, to actually give us the y value in the equation, which doesn't always happen, but it's nice that it happened here. So I get 0, -5. It's my solution for this one. Give you a couple to try on your own here. All right, give those a shot. All right, so the first one here, you got x equals y plus 3. Then you have y equals 4x minus 9. So we're going to take this. As I unfreeze it because I'm an idiot. You're going to take this part, y plus 3, and plug it in for this x right here. So a lot of people kind of forgot to rewrite the y part. So y equals 4 times y plus 3 minus 9. Distribute the 4. Y equals 4y plus 12 minus 9. Combined 12 and minus 9, so 4y minus 3 plus 3. Subtract the 4y. Alright, and now we have negative 3y equals 3. Divide by negative 3. Y should then equal negative 1. So we take our y value, we plug it back up top. We get x equals negative 1 plus 3. X equals positive 2. So our final answer is 2, negative 1. Okay, so the one good part about solving systems, okay, is that you're always able to basically go back and check and make sure everything's on the up and up. And you do that by taking this point here and plugging it in for both x and y in both equations to make sure that you got the right set. So if we plug in x, 2 for x, and negative 1 for 3, in that first equation, we get 2 equals 2, which is obviously true. Okay, so that one works. If you plug it into the top one, it works. Now if we plug it into the second one, we get negative 1 equals 4 times 2 minus 9, which is negative 1 equals 8 minus 9, which is negative 1 equals negative 1, which is also true. All right, so we know we got the right answer. Okay, it does take obviously a little bit of extra work, okay, but you can always go back and plug them in and make sure that you got the correct answers. Okay, if you got something that said like 2 equals negative 5, obviously 2 does not equal negative 5. Okay, so that would mean we screwed something up. Okay, last one here, x equals negative 7y. So we're taking this, plugging it in for x. So 2 times negative 7y minus 8y equals 22. Okay. Negative 14y minus 8y equals 22. Combine my terms, negative 22y equals 22. Divide by negative 22. Get an answer of negative 1 for y. Okay, take that answer, bring it back up top. X equals negative 7 times negative 1. So x just then equals 7. We get an answer of 7, -1.